Hey there, we are back with some more college algebra videos. This is section 4.2, logarithmic functions. We're going to break this section up into two parts. There's a lot of information in 4.2, and so this is all the objectives for 4.2. This first video will deal with the first half of these. We're going to talk about how to change from logarithmic to exponential form and back. We're going to evaluate some logarithms without our calculator, and we're going to talk about some basic logarithm properties. So the big thing about logarithms you have to remember is that they act like different items. They have different rules. They are a different function, and so because of that, if you know their rules, then you're fine. But if you try to apply basic algebra rules to logarithms, that won't work because logarithms have their own set of rules. And the reason for that is because of their definition. The definition of logarithm is that a logarithm function y equals log base b of x means the same thing, is equivalent to b to the y equals x. So if you take a look here, y is in the exponent of this exponential expression, and so logarithms are actually exponents. And because logarithms are exponents, they have their own rules. We'll talk about those rules fully in section 3, but we will talk a little bit about some of them today as well. And so you have to know the rules for logarithms. So the first thing we need to be able to do is to be able to move back and forth between logarithmic expressions and exponential expressions. These are two ways to write the same relationship, right? Just like we can write 1 over 2, or we can write 0.5. Those are two different expressions for the same number. These are two different expressions for the same functional relationship. And so we need to be able to handle that by understanding where each of these variables, y and x, and where the base b happens to belong in each expression. Okay? So let's take a look here. We're going to start with the logarithmic form, and so we have 3 equals log base 7 of x. Now again, what was our rule? Our rule says that if we have y equals log base b of x, that's the same thing as b to the y equals x. Those are the same thing. This is exponential form, this is logarithmic form. So what's playing the role of b over here? 7. 7 is playing the role of b. Right? 7's in the base, 7's the base. Y is all by itself. That's the exponent, so that goes to the third power, and then that means x is what is left here. Okay, let's do one more. What's the base here in this expression? B. What's the power that goes with it? It's the number by itself. Okay, that's 2. And then whatever's left, 25, b squared equals 25. Now we're not solving anything. We're simply rewriting. Okay, we're rewriting in a different form. This is logarithmic form, this is exponential form. Okay, so pause the video real quick and you try this last one. Okay, so what is this last one? What's the base? Doesn't matter what order this is in. The base is the base 4. The number by itself in this case is not a number, it's a variable y, and then the 26 is left over. So this is log base 4 of 26 equals y, and this is 4 to the y equals 26. They both mean the same thing. Okay, they both mean the same thing. Going the other direction, if you have 2 to the 5th equals x, there's a way to write that as a logarithm. How do I write that? Well, the logarithmic form, log base 2, right? Base is the base. And then the x goes here because the power is always the number by itself over here. Log base 2 of x equals 5. All right. If I rewrite this one, what's my base? My base is b. Log base b of 27 equals 3. The power, remember, is always what the logarithm equals. All right. Same thing here. Why don't you guys take a minute and pause the video and try the last one. All right, so this is log base of e. E is the base over here, the number e. So e is the base over here of 33. and that's supposed to equal this power, the power of y. This last one here can show you the power, no pun intended, can show you the strength of being able to rewrite things in equivalent forms, because here if I have e to the y equals 33, I have no idea how to handle that, right? I don't know how to find what y is. But if I rewrite it, I have log base e of 33, and I can plug that in my calculator. You guys maybe don't know how to do that yet, but we'll show you, and then that tells me what y is, right? So being able to jump between exponential and logarithmic forms, either direction, is an essential skill to have for this section. Okay, so you've got to have to go back, and you're going to have a bunch of homework problems on this. Practice, practice, practice until it just becomes second nature. Okay. We're also going to use that to evaluate logarithms. When you see log base b of x without the y equals, what does that mean? Well, it's an exponent, right? That means it's really asking a question. What power of b equals x? That's what this was really saying, because when you have a y over here equals, when we change it, we get b to the y power equals x. So if I'm looking for this y, I'm looking for the power of b that gives me x. So as an example here, a says log base 10 of 100 equals what? Well, the question you need to ask yourself is, what power of 10 to what power gives me 100? Well, 10 squared is 100, right? And so this answer is 2. Log base 10 of 100 is 2. All right? You all try B. Pause the video and try B. Okay, for B, what we have is we have log base 5 of 1 over 125. Well, how are they related? 5 to what power is 125? 5 to the third power. But how do I get it to be flipped upside down, right? The negative power is what flips upside down. So this is equal to negative 3. And the reason is because what power of 5 gives you 1 over 125? This. So it's essential you understand the exponential and the logarithmic forms, but then you got to know what they're asking. If I say rewrite something in a different form, then you give me an equation. If I say evaluate the logarithm, you just give me a number. All right, and you're not using your calculator for this. You're having to crank this out understanding the powers of things. Okay? Let's do a couple of other examples, a little bit more complicated. Here, log base 36 of 6. Okay, so what are they asking? 36 to what power gives you 6? That's what we're asking. Well, I don't really think of powers. I think of square root. Square root of 36 is 6. But guess what? Square root is a power. Square root is what power? The 1/2 power. Right? So this is equal to 1/2, because that's the power of 36 that gives you 6. Right? You guys tell me. What does log base 3 of the 7th root of 3, what is that power? Okay, so 7th root of 3 is the same as 3 to the 1 over 7. So if we say log base 3 of 3 to the 1 over 7, what power of 3 gives us 3 to the 1 over 7? The 1 over 7. Right? That's the power. Okay? So when you have a 1 involved, you have a couple of special relationships. If log base b of b, that's equal to 1, because b to the first is b. And log base b of 1 is always equal to 0, because 0 is the exponent that you need to get a 1. Remember, any non-zero number to the 0 power is 1. And since b has to be a positive number, then any b to the 0 is equal to 1. So log base b of 1 then is equal to 0. Okay. So if you were going to evaluate log base 9 of 9 based on that, what power of 9 gives you 9? 1. Okay. And log base 8 of 1, what power of 8 gives you 1? Well, what power of anything gives you 1? 0. All right, so if you know your basic exponents, then that's not going to be an issue anyway, but just a couple of little quick shortcuts there. All right, so now we know that the logarithm came from, it has a relationship to the exponential function that we learned back in section 4.1. This was our relationship. Okay, it's inversely related. So if you put them together, then what happens? When you put two inverses together, if you remember from chapter 2, when you put two inverses together, they undo each other and you get back x. And so log base b of b to the x is x, and b raised to the log base b of x power is also x. So if you want to evaluate log base 7 of 7 to the 8th power, right? What power of 7 gives you 7 to the 8th power? The 8th power of 7 gives you 7 to the 8th power. Again, very straightforward. Okay? Why don't you all pause the video at this point and try part B. 3 to the log base 3 of 17. What does that equal? Okay, so 3 to the log base 3 of 17. Well, 3 to the power and log base 3 are inverses of each other, so they cancel out and you get 17. But do not, this is not true. This does not cancel that. Do not do that. Okay, that's wrong. All right, but the rule does say if you have b raised to the log base b of x, you just get x back. And that's exactly what we got. We got 3 log base 3 of 17, and we said that's 17, and that's correct. Okay, so that's the first half of section 4.2. Check in for the second section right after this.